Hi everyone, my name is Paige. I am here as part of Deschutes Public Library's virtual programming. I'm joined by Dr. Anders Carlson for our wonderful presentation tonight on glaciers. And the theme for this month that we're currently exploring is no mystery. This is a recently found glacier. And so we'll kind of uncover a little bit about how do you miss something that big right in your own backyard, and all of the other wonderful aspects of this important topic. Our presenter tonight is Dr. Anders Carlson. He fell in love with glaciers as an undergraduate student while conducting research at Matanuska Glacier in Alaska. After receiving his BA in geology and German, he earned an MS at the University of Wisconsin-Madison and a PhD at Oregon State University in glacial geology. Following a postdoc at Woods Hole Oceanographic Institute, he was a professor at the University of Wisconsin-Madison and then Oregon State University before co-founding the Oregon Glaciers Institute. Anders has studied glacier climate change for 20 plus years in the United States, Canada, Greenland, Svalbard, Patagonia, Scandinavia, Antarctica, and he has a newfound focus on glaciers of the Pacific Northwest. Anders, thank you so much for being here tonight. I'm going to go ahead and turn it over to you to get us started.
All right. Thank you, everyone, for coming tonight and virtually. And it's too bad we couldn't meet in person, but someday soon. And let's see here. Let me share my screen. Okay. So keeping with the theme of this month, with mysteries, we'll talk about glacier mysteries here in the Oregon Cascades. And the focus will be on things we thought we knew that we didn't know, and basically a Donald Rumsfeld style speech, known unknowns and unknown unknowns is what we'll be talking about, rather than the known knowns and the known unknown and known unknowns. And so just a brief bit here about the OGE Mission Statement. So Oregon Glaciers Institute is relatively recently founded. We're not a year and a half old yet. We'll be a year and a half old next month. But we formed in May of 2020 during the major lockdown. And so hopefully one of the positive things to come out of that period. And our mission statement is we are to document the health of Oregon's glaciers and their response to climate change to determine their future viability. And then also this side here is educate communities on the roles that glaciers play in Oregon's environment and economy. So these aren't just pretty little things that you ooh and ah over while you're hiking. They actually sustain vital components of Oregon's ecosystems, whether it be from the high alpine zone, the little flowers you see growing along mountain streams, to salmon and trout fisheries, and also irrigation. We'll talk on that in a bit, and when it gets to the economy. So before we start into this, we should first ask, what is a glacier? And this is something that gets confused between a snowfield, permanent snowfield. What is a glacier? Dead glaciers and live glaciers, which will be kind of what we talk about today. What is a living versus dead glacier? And from a physics standpoint, a glacier is an ice mass that flows under its own weight. So the ice has to be able to move without anything pushing it or pulling it but gravity. And this happens once a glacier is at least 100 feet thick. So an ice mass is 100 feet thick. So once ice is reached a thickness of 30 meters, 100 feet, the pressure of the overlying ice is so great that the bottom ice ceases to behave like a brittle material and becomes like a plastic material, and it starts to deform like silly putty or like toothpaste. And that allows the glacier to flow downhill. And that is when the ice can flow, that defines it as a glacier. Now, if a glacier becomes less than 100 feet thick, it then ceases to deform, and it is no longer a glacier. It is a stagnant ice body. It's a dead glacier. It can be transitioning into like into a snowfield, but it is not a glacier. And that's a major distinction. And this is why it's really important, because a glacier, to have that 100 feet thick of ice, is a physical manifestation of climate on the landscape. So how do you get to 100 feet thick of ice? Is you need to have snow accumulating year after year, and it has to survive through the summer. So a glacier signifies that on average, you will be able to ski in that region year round. There will always be snow in the higher zone there because it's cold enough that in the summers it doesn't melt all the snow. And so where the snow accumulates, it's called the accumulation zone. And it's a region here where the snow survives through the summer to build up and turn into ice. And in this cartoon over here, This would be the higher regions here. So this little cartoon of a glacier here showing the line showing the flowing or cross section here. You're accumulating ice up at higher elevations or snow that then eventually turns into ice after many years of snow builds up. So a glacier signifies that you have permanent snow at this elevation, and it doesn't disappear that infrequently because it has to build up over and over again to turn into ice. And once that ice gets up to 100 feet thick, then it can flow downhill, downslope under the pull of gravity, making it to form. It can flow downhill to an elevation where it melts, and it can melt, and it terminates where the climate is warm enough that it can melt away all the ice that is supplied to that region, and that's called the end of the glacier. So the glacier is telling us the climate of the landscape. It is going from a region where you have snow year round. I mean, the snow can melt in the summer, but it doesn't melt enough that it removes all of it. We'll touch on that in the end. That's changing nowadays. But it year-round snow is up there, and it flows down to a lower elevation where it's warmer, where it melts away all the ice it can possibly be supplied. And that then spans a climate gradient or climate zones. And that lower region here is called the ablation zone. So you go from a region where you have snow year-round down to a region where you just have bare ice in the summers, where it's melting, it's ablating. Ablation is a term for glacier melt. If there's any iceberg, if there's a lake that it could be ending in, that would be having off icebergs. And then also another process called sublimation, which is the direct transfer of ice into water vapor. This is what happens in your refrigerator, your freezer, when you put in a ice cube tray into your freezer and you forget about it for several months, and you come back and you have your ice cube trays empty. Your freezer didn't warm up and melt and then the water somehow spilled out. It just, your ice cubes directly turned into water vapor in your freezer. So that's how the glacier works here, is we have this zone of accumulation where ice gets up to 100 feet thick, and then flows downhill to the ablation zone where it melts all the way at the terminus of the glacier. And in between the two is this thing called the equilibrium line. And that is the dividing line between where the accumulation zone is and the ablation zone. Another term for this would be the end of summer snow line. So you go out there at the end of September, early October, right before the first snowfall, and where on the glacier there is still snow, that where that goes from snow to bare ice, that's the equilibrium line. And it's also just, you go up on South Sister and Bend, just west of Bend, and you looked up and you saw snow at a certain elevation, that's the end of summer snow line. And that's the same thing as the equilibrium line. Now, what's important about this equilibrium line is that it is roughly equivalent to the mean elevation, the elevation in the atmosphere, where the annual temperature, the average annual temperature is at freezing, 32 degrees Fahrenheit, 0 degrees C, 0 degrees Celsius. So that end of summer snow line equals also the elevation in the atmosphere, where it's all on average freezing throughout the year. So these glaciers really tell us about the climate. They're climate stations, not weather stations. They don't record any big, brief weather event, and that's changing here as well. We'll talk at the end, but they are telling us what the climate is of the region. And one thing it means is that it's cool enough in the summers that you can keep snow there year round. And so glaciers tell us those kind of things. So let's look here at just some pictures here. So here's a picture of last summer from Crook Glacier near Bend. So here's Broken Top. Bend's right over here to the east, and here's Crook. And you can see here, this is the 2019-2020 snow year here. And then here's bare ice. And so this is right the end of this photo here is from August. And if it snowed the next day, this line here between the previous season snow and the earlier years, that would be your equilibrium line for that year. Now below it, you can see a couple other snow years down here that are previous years, and these still exist, which means that the previous years before the 2019-2020 were better years for the glacier. It snowed more, or the summers were cooler to keep the snow around. And then this bare ice here, that's actually the 2015 year, which was a really bad drought. We had very little snow. And then also until last summer, the hottest summer on record, until summer of 2021. But here's Crook Glacier. It's an active glacier, and we'll be looking at this here. You can see a little crevasse there. My friend Aaron Hart's here for scale. So this is showing you the accumulation zone where multiple years of snow build up, and eventually these will turn into ice. And here's a picture now of Dillard Glacier that can show you how this works. The ice flows downhill. This is on the north side of North Sister. Here's Dillard, right here is North Sister. And here's that, and here's the 2019-20 snow year there. And you can see these layers here in the glacier going across. Those are annual layers. So in the wintertime, we get snow. In the summertime, we get melting occurring. And along with that, we have forest fires, and it's dusty and it's windy. And that blows layers of dust in on top of the snow and make these dark layers. Those are the summer layers in the glacier. So these are like tree rings in a way. And you can count these layers showing you the ice accumulating up here, snow accumulating and then turning to ice and flowing downhill. And there's over 50 layers of ice here in Villard Glacier, meaning the oldest slice in Villard at least dates back to the early 1970s, right when Nixon signed an act, made the EPA and also signed the Clean Air Act, which should be protecting these glaciers from climate change. But it is yet to do that, because so there's a little bit of slight irony here that Villard is actually basically as old as the Clean Air Act, and but it's showing the ice flowing downhill here. Another way to look at glaciers then, is so we talked about it as physical manifestations of climate, and also as a physics thing, just showing you how ice behaves once it gets thick enough and there's enough pressure on it. As we look at them also as a water resource. These are natural reservoirs of fresh water on our landscape. And a way to think about these volcanoes where these things exist is those are like water towers. And I grew up in the Midwest where you have big bulbous water towers in most old towns. Well, in Oregon, our water towers are the alpine zone. You know, our summers are dry here. We tap our snowpack and our glaciers throughout the summer for a water source. And in the volcanoes here, we have our snowpack, but that's usually depleted by August. And then we're only sustaining these streams is our glaciers. So these glaciers are part of our natural reservoir staged water towers. And one way to think about it economically is 85% of Oregon's water usage is for irrigation. So this is for keeping our crops growing and for keeping our animals from getting thirsty. So our economy depends on this water source. And the auxiliary reservoir is the glaciers. Once the snowpack's gone, all you got left is glaciers. And so this is a picture here of Lynn Glacier on North Sister. Villard is just around the corner there. You can see it retreating here. It was in 2004. An active glacier here supplying water into White's Creek that then flows through the town of Sisters, and it's basically gone now and dead as of last year. What happens when you go from here to here is you're losing a constant source. So the stream flow in the late summers in White's Creek going into the town of Sisters into the upper Deschutes River is now permanently lower than it used to be because Lynn Glacier is basically gone. It's no longer, this reservoir is gone. It causes the stream discharge to drop. And what will this mean over time as we lose more glaciers in Oregon is we're going to have to build more reservoirs if we want to store the water. Before, nature did it naturally in these glaciers are disappearing. And so we're going to have to find new ways of keeping water around till the end of the summer when we need it most after the snowpack's gone. And in this time period right now, we're trying to tear down dams. And it might mean we have to build new dams if we're going to try to meet the water needs of our state. What happens as well is the streams get warmer. So this water coming off these glaciers is at freezing, 32 degrees Fahrenheit. It's melted ice directly there. That's really cold water going into the streams. What happens then is if you lose this cold water source, the streams will have a lower flow and they'll have less cold water going into them. So not only are you having less water into streams, and anybody knows that if you boil a pot of water, it's easier to boil a smaller pot of water than it is a bigger pot of water. So the streams will heat up just because they have less water in them. And on top of that, it's going to have less cold water too. And this will start making real problems between the need of farmers and ranchers and golf courses and the citizens of Bend who use glacial meltwater. The headwater of Bend's drinking water is Crook Glacier on Broken Top. They have their water needs, but pulling water out to meet those needs leaves less in the streams for fish, and fish need cold water. The trout and the salmon need cold water. So there's going to be growing conflicts of interest and conflicts of need that'll have to be settled in the courts if we lose these glaciers, because we have only so much water and the water is getting warmer and there's less of it. On top of that, warmer streams equal warmer forests, which will increase fire risk. And so if you look around, this last summer, we had the worst fire season on record until this summer, but this summer's fires were further removed from much of our inhabitants, whereas last summer was definitely burning into headwater near Eugene and then towards Salem. And those fires would have been worse, believe it or not, if it wasn't for the glaciers in the headwaters of their streams. The fire this summer down by Klamath Falls, there were no glaciers there, so that was not, this kind of a comparison doesn't work as well there. But up here, those streams helped actually reduce the amount of burning. Cooler forests don't burn as much, and these streams, cold streams, cool the forests around them. Another thing to think about that's occurring with these glaciers retreating and loss, or they do, is we're going to be actually making more hazards. As glaciers retreat, they expose lots of unconsolidated sediments. All the moraines, all this goop and the rocks there are now on the landscape where they can increase debris flows, landslides. And another problem is they can increase flooding. And this is a case here. This is Carver Lake on north side of South Sister, bends right over here. Sisters is up here. This feeds into White's Creek. And right above it is Prouty Glacier, which is a broad, flat glacier that feeds right into this lake. And this lake, if it were to breach this dam, the flood that would go through the town of Sisters would exceed the 500-year flood, which has never been recorded. It would exceed any possible flood potential that's ever been seen in the town of Sisters and more or less wipe out the town. And that could occur if we have a heat wave hitting, again, Prouty Glacier and causing lots of melting, going into the lake. It could breach this dam, and away it goes. And right now, nobody's monitoring this. These are growing environmental hazards to the people of Oregon and the infrastructure of Oregon, and not a single thing is being done about it. Here's what's weird. So we have these glaciers are water reservoirs. And if we ever put up a dam on a river, we were required to know what goes into the dam, flows into behind the dam, how much water goes out of the dam, what's the volume of water in the dam. And we do the same with, because that's a water resource. And glaciers are just like that. They're a naturally occurring water resource, but they're not being monitored at all. And by not monitoring them, we're also not knowing how they're changing. And in addition, how they're changing can be greatly increasing the hazards to the residents of Oregon, and also causing lots of economic damages, whether it be wiping out roads or cities, or just loss of water resources in general. So kind of then the mystery here is, what is the state of Oregon's glaciers? Since we founded this institute because absolutely no monitoring or understanding of how these glaciers are changing and what their impacts are is occurring in Oregon. The state and the federal government is just not doing it. So that's why we did this. And so the first question we kind of set out with this in funding the institute is, how many glaciers do we have left in Oregon? What is the state of these glaciers? And a similar talk could have been given 83 years ago. Up until basically the 80s, the Mazama Mountaineering Club in Portland, Oregon, did kind of monitor the glaciers of Oregon. And in 1938, I believe this was written, this guy, Kenneth Phillips, who's a Mazama member and was also a civil engineer for the U.S. Geological Survey, wrote this great paper about our vanishing glaciers. They were realizing the glaciers in the Cascades were retreating and what was causing it. And there was a lot of interest in glaciers in Oregon up until the World War II. So the history here of glaciers basically in Oregon, we can start off here in 1837. Louis Agassiz, a Swiss scientist, proposed a hypothesis of past ice ages. And in 1940, he published his book called The Studies on Glaciers. He invented the field of glacial studies, which is called glaciology. But after this was published, people thought that the lower 48 states of the U.S., so the contiguous United States, were glacier-free. And it wasn't until 1870 that the first glaciers were discovered in the lower 48, and that was on Mount Shasta. And then a few days later, glaciers were discovered on Mount Hood. And so we didn't know there were any glaciers in the United lower 48 outside of Alaska until 1870. And quickly things exploded after that. In 1885, U.S. Geological Survey geologist Joseph Dillard, who has a glacier named after him, Dillard Glacier on Middle Sister, wrote these words as probably that the Three Sisters region, so nearing Bend, probably affording the most interesting field of glacial studies in the United States, with the exception of Alaska. So Oregon's glaciers were considered by the USGS in the late 1800s to be the best place to study glaciers outside of going to Alaska, where there's a lot of glaciers. And then people did that. In 1938, though, Ken Phillips wrote his thing, Our Vanishing Glaciers. And in 1939, he wrote another thing, article the Mazama publication called Farewell to Shoals Glaciers, where they documented the disappearance of this glacier, Shoals Glacier, on Mount McLaughlin, which in the 1890s still had a glacier that disappeared by 1938 when they went there, and they wrote this article in 1939. But he wrote at the end of this, why are our glaciers receding? Who knows? Perhaps mountaineers of the fairly near future may look upon empty cirques of Mount Hood as a normal condition. So at this point, glaciers were retreating, and they were even having this idea that Mount Hood could be glacier free in the future. The reason why they're retreating then is Oregon was coming out of the Little Ice Age. Climate was warming up and the glaciers were retreating. And why the Little Ice Age ended is an area of hot debated research, and there's not a conclusive answer to that. But humans were definitely involved in some way, shape, or form with early releases of greenhouse gases into the atmosphere as we went through the industrial revolution. But exactly how much we contributed versus natural causes is unknown really at this point. Unlike currently today, where it's 100% us. And so there was a lot interested in this, and then the U.S. entered World War II in 1941, and we, had other things to worry about than glacier retreat in Oregon. World War I ends in 1945, and we enter the late 40s into the 50s with a booming U.S. economy. The USGS then made the great topographic map series that we have today that everybody uses for camping and backpacking and for legal agreements and so on. So this is a U.S. government's codified record of what is on our landscape. And in the 1950s, Oregon was declared by the USGS as having 36 official glaciers, of which 35 were in the Cascades and one was in the Wallowas, Benson Glacier. And oddly enough, in the Cascades, they never updated the maps. The Wallowas glacier extents were updated in 1980s. Other states got updated: Washington, Wyoming, Idaho didn't have any glaciers, but Wyoming, Montana, but not the Cascades. The Oregon Cascades, the glacier outlines on all federal maps, and whether it be Forest Service, and then all the people who utilize those things in, Caltopo or these other map products that exist today, all the outlines are from the 1950s. And so we don't know what has happened since the 1950s in Oregon. And a lot has happened since the 1950s. So that's where we get to where we are. For one thing that's happened since the 1950s is climate got warmer. We don't really have good records of climate change or weather in the high alpine zone. We really have none. We don't have any good temperature records below the high alpine zone. So we're on tree line until the 1980s, when the U.S. National Resource Conservation Service, NRCS, put in place what's called the SNOTEL network system, which measures snowpack and temperature. These are very nice instruments, and they can go up to tree line. They can't go above tree line for how they're designed. But these didn't exist until the 1980s. And so really, if you wanted to know what the temperature was in the Three Sisters region in the 1960s or 70s, you'll not know it. You have to use some kind of product that's a modeling result, not actually, there's no weather stations there. So we really don't have anything till the 1980s, what's going on in these regions. And this instruments they put in place really didn't start working until the 1990s. So we can't go back to the 1990s. And over here is showing you then these white things are where SNOTEL stations are recorded. And orange ones are ones that do not have snowpack records with them, but just temperature records. But then the white ones are temperature and snowpack. Anyways, this is showing you what we know about temperature change near the where these glaciers reside, and it's not a lot of coverage. But what we do have, this is showing you now the temperature change on an annual average temperature. So you see here's relative. This is a change in temperature relative to this period here of 2009 to 2013. And then here's the summer temperature, which is when the season when glaciers melt. So this would be recording you. This is equivalent to what's happening with that equilibrium line. So how's the annual temperature changing? This is telling you like how much energy the summers are giving, so how much can melt a glacier. And both have been warming at about 1.7 to 0.8 degrees centigrade per decade, so 1.5 degrees Fahrenheit per decade. That's really rapid warming. And so easily over the last 3 decades, you've seen at least 2 degrees centigrade. So, 3-4 degrees Fahrenheit of warming occurring near the high alpine zone where these glaciers reside. So it's been warming. And what happened before the 1990s, there's not a lot of records. So what is then that doing to the glaciers here? And this is where we get into going around trying to see how many glaciers remain in Oregon and how many actually existed to begin with. So this is, we have to separate out living glaciers, ones that are flowing and deforming, so hitting that 100-foot thick mark, or dead glaciers, ones that no longer flow. And so here's Lynn Glacier on North Sister. It is a dead glacier. It's still got ice there. That ice is not moving. It is stagnant, whereas in 2004, when I took a photo, it was definitely still moving ice and an active glacier. So in the last 16 years, Lynn went from a living actual glacier to a remnant patch of ice on the landscape. Well, the first thing we can look at is evidence of flow. And so short of going out and measuring the thickness of glaciers, we can just look for flow evidence. And the first bit of flow evidence is crevasses. So the cracks on the surface of the glacier. So while ice at 100 feet thick is deforming and moving, that's only the bottom ice. Above that, the ice pressure on the ice above that is less because it's not as deep in the glacier. And so it's still brittle. And so to keep up with the basal ice moving, the upper ice cracks. And that makes crevasses, and that shows you evidence that the glacier is moving. So here's Bend Glacier on the north side of Broken Top. And this glacier is on its way out. It'll stagnate very soon. It doesn't have an accumulation zone anymore. This photo is from late August, and by the end of the actual snowfall in 2020 that occurred in mid-October, there was no last year's snow on this glacier at all, and the same thing happened again this past summer of 2021. So it's still thick enough to flow, but it's a starving glacier. It's no longer accumulating mass, and so Bend Glacier will soon cease to be a glacier. But it is still one right now, as evidenced by the crevasses there. Now, another feature that shows us that a glacier is flowing is that that movement on the bed scrapes the bottom of the bed of the glacier, scrapes the underlying rock and sediment. So in the case of Oregon volcanoes, there's a lot of volcanic ash and cinders and so on. And those get scraped up and make what's called glacial flour, fine-grained sediment in glacial streams. So this is Carver Glacier here on the north side of South Sister. And if you look at the water coming out of its terminus here, it is chock full of sediment. So this means Carver is still eroding its bed, and it is still an active glacier there. And the last way we can do this is looking at the terminus here. This is Lewis Glacier. So here people hike, I'm at the south side of South Sister. You can see them for scale walking up the moraine. And this is Lewis Glacier. It's got a convex terminus. So the ice is flowing forward, it's moving, it's flowing out into space, where it then hits this wall of hot temperatures that are melting it. So this thing is moving forward, belching out. Whereas a glacier that ceases to flow will have a concave terminus. It's being melted back in. It's not moving forward into like a slicer of chopping through things. It is rather being melted back. So you can look at the different terminuses to see how it works. So let's look now at what glaciers remain in Oregon. Let's look for some mysteries here, like how many remain, how many existed. And this is a map here showing you the 36 named glaciers by the USGS in the 1950s in Oregon. We have 35 here in the Cascades, and the one in the Wallowas here, Benson Glacier on the Eagle Cap Peak there. We'll start off with the southernmost glacier in Oregon, Lathrop Glacier here down by on Mount Tilson, down by Crater Lake. And I mentioned Mount McLaughlin, that's right here, that had a glacier in the 1890s and it was gone by the 1930s. So it's not falling within the kind of window we are doing here, checking the USGS's maps. So Lathrop Glacier was the last glacier added to the maps and identified. And here's a picture of it from 1965. It's a very narrow glacier on the north side of Mount Tilson. And it's being basically fed by avalanches that are stacking up, turning into ice. And so it's 100 feet thick in the direction of gravity. So it's a really steep glacier. The direction perpendicular to the surface here would not be 100 feet thick, but in direction of gravity, it does get 100 feet thick. And it was still actually a glacier as of 2013. We have some people have hiked and given us evidence of that, taking census photos, but by 2020, it was gone. And so Lathrop Glacier is no more. And it is a stagnant dead glacier, or it's a gone glacier, completely ceases to exist. So that was Lathrop. And we can move further north here, but we have to stop. Here's a surprise to us, a mystery. I wish we were in an actual audience because I could see you raise your hands here. Who thinks Diamond Peak had a glacier on it in the recent past? And it was really recently. So this one threw us for a loop. So here's a USGS map of Diamond Peak here. So Willamette Pass is right up here, the ski area. And here's Diamond Peak. If you look at the map here, there's no glacier, no permanent snow ice body on it. Well, here's a sad air photo from 1949 showing that at that point there is this white body here, and in the 1930s, Ken Phillips' paper, there was definitely still Diamond Glacier on Diamond Peak in the 1930s, but maybe it was gone by the 1950s. But 1949, there's still, you can see there's this snow body here. If you look, zoom in closely, you can see there's ice in there. And then at the end of this talk, I'll give you a link here for where we've been looking for people to send us photos, some of their old photos. Here's a photo sent to us from 1971. Taking this guy took his kids out hiking to climb up Diamond Peak, and there still is a glacier there with crevasses, still flowing down, slightly convex shape there nearing the end of its lifespan. But in 71, 20 years after the USGS made its topographic map series, you still had a glacier on Diamond Peak. So there's a big oops there on their part. And at least in the 1930s, or actually in the 1920s, there were 5 glaciers on Diamond Peak. You can still see some of the snow remnants here in 1949. Whether these are active or not, or still, it's hard to say. But Diamond Glacier, the big one here off the west side, the north side of the summit, was still active in 71. So that one never made it on the maps, period. And here we have one that everybody should be near and dear to them. That is, well, it's kind of put on the maps. It wasn't called a glacier, on Mount Bachelor. So Mount Bachelor ski area has on the USGS topographic maps this snow or ice body here, unnamed. This is actually called Dutchman Glacier, but they never bothered to put it on the maps. And it was unofficially called Dutchman Glacier, and it's completely gone now. This is last summer showing you there's nothing there, but this is what it was in the 1950s. And it was still probably an active glacier up to the 1980s, early 80s. A guy told us he was skiing off the summit and you can still see crevasses on the glacier. Here's a photo from the 1960s showing you there's ice there still moving. So the USGS did put a snow or ice body on the map, didn't name it as an actual glacier, and this glacier was still there at least as of the early 80s, flowing off the summit of Mount Bachelor. Moving to Broken Top here, I showed you Crook Glacier still being an active glacier and Bend Glacier being an active glacier, but Bend may be on the way out. It's harder to say with Crook. Here's what it actually looks like now. So these things, there's way less white on the map. And there were 2 glaciers that were active glaciers that were not named, even though there's snow and ice bodies here, which we're informally calling East and West Bend Glacier. So East Bend Glacier was still relatively active, and it's next to an unnamed lake called No Name Lake. That's the lake that came off, it was dammed up behind the moraine left by this glacier. And it's got a smearing of ice left here. You can see, so it's similar to Lynn Glacier, but it's no longer an active glacier anymore, but there's a little bit of ice left. Then there's West Bend Glacier over on this side here. Here's Bend Glacier proper. Here is this area there where the glacier was. You can see this large moraine ridge here that was deposited by it that is no more. So Broken Top actually had 4 active glaciers in the 1950s, of which 2 remain today. We can move now to the Three Sisters here themselves, which was described in 1885 as being the best place to study glaciers outside of Alaska. And we still think so, but it's a good place to study glaciers that are vanishing. So this is what the maps look like in the 1950s, and this is what the maps look like today. And this is what it actually looks like today. There's a lot less white on this photo than there is on the satellite image from October 10 last year versus what is shown on the maps. So you start going through these glaciers here and seeing what remains and not remains. And first off, we have Clark Glacier here on the west side of South Sister. This is one we, a year ago, had a funeral where we had a casket on the Capitol steps of the state of Oregon in Salem to signify the loss of this glacier and raise some awareness over the glacier disappearance that's occurring within Oregon. And so this glacier here is a smearing of ice left. It's no longer active ice. And there's a dog for scale showing you how few little ice is left there. So Clark Glacier is no longer a glacier. Moving around here, I already showed you Lewis as an active glacier. Here's Prouty. This is above Carver Lake. I showed it earlier, but there's a good picture of it. You can see some crevasses here. This glacier is very thin. It doesn't have an accumulation zone anymore. It is nearing the end of being a glacier. So Prouty will soon stagnate and disappear like Bend Glacier is. So it's kind of in the, it's no longer taking in any snow. It is only melting. It just happens to be thick enough still to deform and still be a glacier. but it's in hospice care, you could say. You're just visiting it now to wait for it to pass. Come around here to Carver Glacier, and I already pointed that out in the photo here of it being an active glacier with all the glacial flower in the stream. But here we have a thing here. Carver Glacier on the map is actually 3 glaciers. The USGS put one name for what was actually 3 different glaciers. You'll notice up here above this glacier here, there's another moraine. And there's even one below it here. So you look on the map here, here's this one, here's this one, and this is the middle body here is Carver Glacier. That one's still an active glacier. The other 2 are, one is gone and the other one's a stagnant ice mass. This is moving south here. This is the one above Carver proper. We're calling South Carver Glacier. That's a recently stagnated ice body. It's concave, building up debris on it. It's no longer flowing. There are no crevasses. So this one has recently stagnated and is no longer a glacier. And then moving down towards Camp Lake here, here's another part we're calling North Carver Glacier. And you can see it deposited a moraine running along here. It's a slight smearing of ice left right there, but it is gone now. And so it is no longer there. So Carver Glacier is actually 3 glaciers, of which 1 remains today. Same thing would be true of Skinner Glacier over here, which was when mapped by the USGS, they put one name for 3 glaciers. And there's 3 different bodies here, and they're broken up. We have Skinner proper, what we're calling North Skinner, and then South Skinner here. And South Skinner may not even have anything left. Here's a snowfield there. This is from mid-August last year, and by the end of August, the snow is gone, period. So it's completely vanished. Skinner proper is nearing the end of its life cycle here. There are no crevasses that we could see by the end of the snow, but it's barely convex terminus here, almost becoming concave. These things here are not crevasses. That's actually meltwater cutting into the glacier itself. So it's nearing the end, and we didn't get back to it this summer 2021, but it actually could be gone now. And then North Skinner Glacier down here, for the north, it's got a convex terminus there, and it's got glacial flower in its meltwater stream as of last year. But Carver, the glacier left to Carver, and then the 2 ones remaining for Skinner are probably nearing stagnation themselves, and probably easily, if not this past summer 2021, we made this massive heat wave. Not then, in the near future, it will probably no longer be glaciers. And then here's the surprise. We found a whole new glacier while doing this. And it really threw us for a loop. So here's Skinner Glacier here on the map. And here's Carver. And then there's this area here on the north side. It's always in the shadows, where if you look around it at that same elevation, all around South Sister, there's glaciers there. And then on the USGS maps, and this is a US Forest Service map, there's nothing. And it turns out there is a glacier there. This is what we're going to call Ruspin Glacier. It's not official yet, but you can see there's crevasses. It's got a lot of rock fall on its terminus here, but it's got an accumulation zone. So this is a whole brand new glacier that was never put on the maps, never been documented. That's been sitting there for centuries and centuries next to one of the largest metropolitan areas in Oregon. And nobody ever noted it, period. So quite a shock to us to find this. When you're out there documenting the disappearance of glaciers, to find a whole new glacier. This doesn't mean that it's climate cooled in this region like that. It just got completely missed by the mapping by the federal and state governments, which shows you how little effort and time has been put into documenting Oregon's water resources in our high alpine zone by our state and federal agencies. So there's a whole new glacier here, and with it being located on the north side and always in the shadows, you see it doesn't get much direct sunlight. This might be the last glacier to still exist on South Sister if the other ones disappear, and maybe in the Three Sisters in general. So a little bit of irony, the last one never discovered might be the last one also to go. Right next to it is Eugene Glacier here. This one recently stagnated. It's split up into multiple ice masses, and these are becoming concave. You can see this meltwater here. You can actually see through the water. There's no flower in the meltwater. And so this is what a recently stagnated glacier looks like. And so this is basically what Skinner and Carver, the remains of those ones, glacier complexes or multiple glaciers that were those are going towards. It will probably be like these in the very near future. So Eugene very recently became no longer a glacier, although there's still a fair amount of ice left there. And lastly is this one over here, Lost Creek. which is still an active glacier flowing at the northwest side. It is got a lot of debris cover on it. This is just a zoomed in satellite image here, but it is still a relatively large, long glacier here flowing on the northwest side of South Sister. And lots of people ask about this one up here on the summit, this drop, the pool up on the summit here where there's a big ice mass. Well, and that one is an ice mass up there. In the past, it actually flowed over the top down into Feeding Lost Creek Glacier, but it doesn't flow now. It's a stagnant ice body that sits there and gets a lot of snow, but it is not a glacier because it's not moving. It doesn't show evidence of moving. So that's a stagnant ice mass that actually used to be kind of part of probably Lost Creek Glacier, and at least during the Little Ice Age, 150 years ago. So moving over here to Middle and North Sister, we're just going north here. Here's Irving Glacier, and now Irving Glacier is actually two glaciers. Both of them are recently stagnated ice. Here's Irving. You can see its concave terminus here. It's just kind of an ice patch left on the landscape. There's what we're calling South Irving, this other ice patch here, and it's concave. You say, wait a second, aren't these all crevasses? These aren't crevasses. These are actually collapse features. There's a big melt cavern going back under the glacier. I think Washington Post just had pictures of these ice caverns in Austria that they just had a photographer out documenting. This is the same thing here in Oregon, and this one just collapsed in on itself. So this is breaks from the ice roof collapsing in under this chamber. So both of those ones are gone. A couple glaciers that were not put on the maps here. So again, lowercase g, like South Irving Glacier. So we're calling Chambers Glacier. This is moraine here. You can see a little bit of ice left there. This was a glacier feeding in towards Chambers Lake. And also by Camp Lake, there's this little ridge here. There's a small moraine, and this snow patch here is hiding a little bit of ice that's left of what we're calling Camp Glacier. That was these small little glaciers on the landscape here, kind of like Irving, that just never got a name added to them, even though there were snow and ice patches put on the maps. They just weren't named. So the big kahunas here for the Middle Sister are HaydenDillard Glaciers. These are still very much active glaciers that have retreated an awful lot from their mapping, particularly Dillard, which you can see here based on this map here, extended down to near these moraines, and that's retreated back up. But these are still active glaciers there. Further coming up around here is Thayer. Now this one is completely gone. This just happens to show a lot of snow there right now. But if you come back in late summer, early August, there's no snow there, period. That one's gone. I showed you photos of Villard showing there was still an active glacier. And here's Lynn that was recently stagnated in the last 16 years, 17 years. In between, you see this little snow ice body there. That's what we're calling Crook Glacier. And then there's photos from the 1960s that showed it was still an active glacier then with some crevasses, and now there's nothing left on the landscape there, period. But so unofficially, it's kind of wedged into a crack between these two larger named glaciers. And we wrap around here now to Collier Glacier. This was the largest glacier in probably by volume in the Three Sisters region. Prouty was the largest by area. And that has retreated extensively from where it was in the Little Ice Age, but at the time of glacier mapping, it was extending down to about here. And so you can see the amount of retreat that's occurred since the 1950s, which has never been updated on maps, but it's still an active glacier there. You can see the crevasses on it, and it's still flowing. But it's retreated an awful lot, and that's not been updated. Then lastly is Renfrew here. And this glacier, this is a photo from 2020, and we said it was still technically an active glacier despite these areas here being like concave, maybe a little convex. And we went back to this year at the end of after the heat wave hit, and it is no longer a glacier. So Renfrew just died buried this last year or so. And so it's no longer an active glacier, but it's a stagnant ice mass, just like Eugene or Lynn are. Particularly, it resembles Eugene. So that's the Three Sisters region there. And for time's sake, we'll kind of skip over, and we'll kind of move quickly through the remaining glaciers here of the region. And I just thought I'd really focus in on the glaciers around the Bend region there. And we have our official one, but we have one that probably many people saw and looked at, and it's even been talked about in U.S. Geological Survey literature, but was never put on a map. And that's Jack Glacier on Three Finger Jack. On the east side there's a large moraine. People hike up on it all the time. As of the 80s, there still was a glacier terminating in this lake here, calving off icebergs. Here's some people that were not with us hiking there, and it is gone now. So similar to Thayer. But that was one that was completely missed. That is very well known by scientists and federal government. That was never put on maps. Let's move over to Mount Jefferson then. And on Jefferson, only 2 glaciers have disappeared, of which one is sometimes named on maps by the USGS. So the ice extent doesn't vary, but whether or not they put a name on the map does. And so different years that the USGS updates their maps of new roads or new houses, they never updated the ice extents, but sometimes they call this glacier here on the west side of Mount Jefferson, Milk Creek Glacier. It is completely gone. You can see there's nothing there. Then there's one here that has still been put on the maps. It was down by Timberline. It is gone. It's called Timberline Glacier. They never named it, but it was on the maps. So that is one that's disappeared. The remaining ones, Russell Glacier, Jefferson Park Glacier here on the north side. Whitewater Glacier, which is the largest glacier by area in Oregon, is still there. And then this one here, Wallow Glacier, is still technically an active glacier, but it's almost certainly near gone and probably be gone in the near future, if not. So it's nearly on its way out. Same time, Whitewater Glacier is breaking up into multiple glaciers. And so it should probably be named 2 different glaciers here because this is a separate ice body now over here that's separated from this one as this ridge melted through. So lastly, Mount Hood. Mount Hood is, again, like Mount Jefferson, had only 2 glaciers disappear on it. And it has had a lot of retreat go. This is what the federal government recognizes, and what's on every map is how white Mount Hood should be. Here's what Mount Hood actually looks like. And the most notable thing here is its south side has got hardly any white, whereas according to the federal government, it should have a lot of white, and it doesn't anymore. The biggest one that pops out here is Palmer Glacier is gone. And this is the one that people ski on. Here's a ski lift going up to Palmer Lift up here to what Timberline Lodge maintains as the summer ski operations. And nobody ever shows you photos from what Palmer looks like in October, but this is what it looks like in October. It's just a couple bit of snow there. And there's been debate about whether or not Palmer ever was a glacier in recent history. And as of 1981, it was. The USGS, after the eruption of Mount St. Helens, was very worried about other volcanoes erupting, and with all these glaciers on it, these things could rapidly melt and cause lahars, which are volcanic-related debris flows. And with glaciers, volcanic eruptions, and all this sediment around, you can make really bad lahars. So they set out to measure the thickness of glaciers in the Three Sisters regions, also on Rainier and Hood, not on Jefferson, but on Rainier, Hood, Jefferson, Shasta, and the Three Sisters region. In Palmer, they measured, had over 200 feet thick of ice in 1981. So it was actually a glacier then. When it disappeared as a glacier, it was probably somewhere in the 80s, because by the 90s, you could start seeing evidence that it was at points snow-free. And this is an example where if we wanted to team up with companies, what Timberline Lodge does by maintaining this summer ski operation is they make an artificial glacier. They are mining, they are packing up snow, they're storing snow that then is allowed to melt throughout the summer, just like a glacier melts throughout the summer. And they're sustaining streams that without the actions of Timberline Lodge would run dry. So while people are like, oh, look at all this human activity and it's not natural, but so is our emissions of greenhouse gases to the atmosphere, and that's getting these glaciers to disappear too. So Timberline is actually doing something to simulate and counteract what would other be a much worse condition here. So they make money and educate kids how to ski, while at the same time, an added benefit is it keeps streams and this ecosystem up here still going that would otherwise disappear in this little drainage basin here that was being fed by Palmer. You see up here, White River Glacier and Coleman Glacier here. These are still active ice masses. And the other one to disappear was Glisson Glacier here over on the northwest side. Here's what's left, smearing of ice. Here is Sandy Glacier, still an active glacier, and Ladd, Co, and these other ones are all active around it. And this glacier has disappeared relatively recently. We have a photo from 2003 showing that Glisson was still an active glacier with crevasses on it, and now it's just a smearing of ice left there. So to kind of wrap up here, here's the list of the official glaciers in the Oregon Cascades. And I've drawn lines through the ones that are stagnant or gone. So Lathrop on Thielsen, Clark and Eugene on South Sister, Irving and Renfrew on Middle Sister, Lynn and Thayer on North Sister, Mill Creek on Mount Jefferson, and then Palmer and Gleason on Mount Hood. I put asterisks by ones that are nearing where they probably will just stagnate in the near future and no longer be glaciers, like so Broken Top, Crook and Bend, Prouty, Carver, Skinner. Then Zigzag on Mount Hood is still technically an active glacier. It's got slightly convex terminus, but it doesn't have accumulation zone anymore, and the crevasses on it are healing up. We looked at it last year. After the heat wave this last summer, it actually could be a dead glacier now. We have to go back out and check on that, just like we have to do these other ones here in South Sister. But if we go to our unofficials list, we add in a lot more glaciers. Showing here, Diamond Peak, Mount Bachelor had ones, the West Bend, East Bend. Counting for the actual true number of glaciers on South Sister increases its number, adding a one that's still there and an active glacier that isn't going anywhere anytime soon. Same is true on Middle Sister, and then adding in Timberline here on Mount Jefferson. So let's put these numbers here, actual numbers on this, and go back to that. What is the state of Oregon's Cascade glaciers? Well, if you count it up, Oregon Cascades in the 1950s had 50 glaciers on it. A nice round number, but the odds of getting actually 50 glaciers, counting 50 glaciers in Oregon Cascades is the same odds as counting 51 or 47 or 53. So it just happens to be 50. We didn't make it rounded even like that on purpose. And of that, 27 remain today. So 23 glaciers have disappeared, have ceased to flow and have died, and even some completely disappeared from the Cascades over the last 70 years. So that's 46% of these glaciers are gone. Now, it doesn't seem like a lot, but think about it like this. Minnesota is a land of 10,000 lakes. And what if they had to go there and update their license plate to say, no, we're the land of 5,400 lakes? That's what this is equivalent to. We could say Oregon, the Cascades, is the land of 50 glaciers, and now we're 27 glaciers. That's how bad it is. And Minnesota wouldn't want to be proud of their license plate after saying we actually now are the 5,400 lake state. That's what's happening here. You just gotta, and glaciers are just like a lake. They're a permanent water body on the landscape that is disappearing. So here's a picture from the north side of Mount Hood showing you Elliott. Here's Coe coming down. No, this is Elliott. Here's Coe, and then here's Langell, and then you can see Ladd over here. So those ones are all actively flowing glaciers. But let's put it here by the numbers. I just said in the 1950s, Cascades had 850 glaciers. 27 and 19 and then 21. So that's 46% of Oregon's glaciers in the Cascade are dead and gone. Now, we didn't talk about the Wallowas, and I mentioned they had one named glacier, but in reality, they had at least 10 or so glaciers there. So you could say Oregon had at least 60 glaciers in the 1950s. Now, the Wallowas are ice-free, glacier-free. The Benson Glacier, the one named one, just a smearing of ice left. It's not an active glacier. And all the other glaciers have disappeared from there as well. They were never named. So we had those up. We've lost more, and saying that Wallowas had at least 10 glaciers. Oregon's lost at least 55% of its glaciers in the last 70 years. So more than half of Oregon's glaciers are gone. And on top of that, we have about 7 that are likely relative to die soon. So the 2 of the Skinner glaciers, Carver, Prouty, Crook, Bend, let's see, Prouty, Waldo. These are all going to go soon. And so that 27 will go down to 20. And then at that point, 60% of Cascade glaciers have disappeared, not 46. So what remains here? Well, the glaciers that we have left are on Broken Top, Three Sisters region, Jefferson and Hood. The Wallowas, Mount Thielsen, Mount Bachelor, Three Finger Jack are all glacier free. And if you're ever on Jeopardy and this question comes up, if you want to know the southernmost glacier in Oregon, it's Crook Glacier on Broken Top. It used to be Lathrop Glacier on Mount Thielsen, but it is now Crook Glacier on Broken Top, if you ever get asked that. Yeah. So what's driving this? Well, it's the climate warming we've been occurring since the 1980s or so. So nearly half of the Cascade glaciers are gone. And over the last 30 years, that's over the last 70 years. And as I mentioned, we don't have records that go back to there. So for much of people's lifespan that are listening to this talk, prior to 1990, we don't know what was going on in those regions with in terms of temperature. Despite the fact that TVs, radios, we put people on the moon, didn't know what the temperature was in the Three Sisters Wilderness. So it's kind of crazy how little we know about these regions. And so if you look over that since 1990, it's warmed about 3 degrees Fahrenheit at a mean annual level. So taking this curve here, it's warmed about 1.5 degrees centigrade. So that's about 3 degrees Fahrenheit. And if you turn that into what that warming of the average annual temperature does, that'll be moving that equilibrium line up in elevation. And that equilibrium line goes above the top of the glacier, the end of the summer snow line. That means the glacier can't get any snow. It's starving. And after many years of starving, it'll eventually thin so much because it never took in ice, new ice. It only burned calories. It only melted ice. And eventually it thins so much it stagnates, like we saw with Renfrew recently, or Eugene. And then it ceases to flow and it's no longer a glacier. So what causes glacier death is that snow line on a permanent basis rising above the top of the glacier. So this would have raised snow lines since the 1990s by over 1,000 feet. Now we can look at the glaciers that have disappeared versus not disappeared. And so this is in meters and Celsius here, rather than feet, but I can make some calculations here. So so this is showing you latitude north. So here's Mount Thielsen, here's Diamond Peak, Three Sisters region, here's Mount Bachelor, here's Jefferson, Three Finger Jack, here's Jefferson. What this is showing you then, and each dot is a glacier, and red are glaciers that have ceased to flow, it's stagnated, or fully disappeared. And on the left here is showing you the elevation it would take to raise that snow line above the top of the glacier and trigger this starvation period before it eventually stagnates and dies. And on the right is showing you what that is an equivalent mean annual warming to raise that snow line up. And the red then are glaciers that are gone and the blue are ones that remain. And if you look at this, the red ones are kind of all around less than 200 meters, less than 660 feet of equilibrium line rising, or about a degree Celsius of warming, a little over 2 degrees Fahrenheit, maybe a little more, 2.5 degrees Fahrenheit warming to get rid of these glaciers, whereas the active ones are showing require more warming to do it. But the amount of warming that we've actually seen since 1990 is more than sufficient to have caused these glaciers to die. So this is a climate-driven die-off of these glaciers. This is not some part of a natural cycle or anything like that. This glacial loss is driven by the warming of the climate, which is what we are causing. And as I mentioned here, so like we've actually raised it 1,000 feet, so 300 to 370 meters. So that's right in here. And this may be saying, like I said, like, Prouty, Bend, some of the Skinner Carver glaciers are on their way out. Well, that may be they're just trying to catch up. They've ceased to have an accumulation zone, but they're still flowing because they're still thick enough to flow. But they're soon going to actually catch up with the climate warming that's occurred and will cease to be glaciers. Now, it still leaves these larger ones up here on the Jefferson and Mount Hood region here that we're going to require more warming, but that could be in store. So what we have here now, what is to come with the glaciers that remain in Oregon, really depends upon what we do now. So we have future known unknowns. We can predict what we do now and how we use fossil fuels and how we get off of fossil fuels will determine how many glaciers remain in the Oregon Cascades. What we have right now is glacial loss is already showing the impacts of human-caused climate change in Oregon. I would argue this is the best indicator of this because we can have snowy winters and dry winters, but the glaciers really are recording this long-term warming and changing of our snowpack from good snow years to rainy years or dry years like happened in 2015. As we go into the future, what we're looking at, these are two different pathways here of carbon usage, so representative carbon pathway. And this one here, this RCP 4.5, this is kind of the pathway that would cause global warming of about 2 degrees centigrade, so globally average over the planet, which is something that we don't want to hit. But you can see this is still somewhere in the mid-century. We start weaning ourselves off of fossil fuels. Even at that point, it will still warm the Cascades in the summer by 6 degrees Fahrenheit by the 2050, more than 4 degrees Fahrenheit by 2050, and more than 6 degrees Fahrenheit by 2100. Now, the pathway we are on, because we've absolutely done nothing to curb our carbon emissions at any time in my lifespan, and we've yet to do anything, even though we talk a lot of rhetoric, is this one here. And this RCP 8.5, this will cause at least 4 degrees centigrade of global warming. This means by by 2050, we're going to be warming the areas here in the Cascades by 5 degrees Fahrenheit. And by the end of the century, 12 degrees Fahrenheit. This is an insane amount of warming. And this will doom these glaciers. But what happens now, what pathway we choose, kind of like a choose your own adventure book, will determine what happens in the future. So the mysteries of the future can actually be solved now by what we do. And the now is already really bad. So I just mentioned it's 2021. This is what it looks like now. This last summer was unbelievably bad with that heat wave. And what it did is, not only did these glaciers, only one glacier had an accumulation zone last summer. That's Hayden. His little white bit. This is a satellite image from end of September, right before that, or mid-September, right before the first snowfall we got. That's all the snow that remains. For a glacier to be healthy, you should have 2/3 of its area have snow on at the end of the summer. This is all the snow we had anywhere in the Three Sisters Wilderness area here. It's right on Hayden. Now, Collier here, not only did it melt through all the snow, it melted through all the previous summer's snow going back to 2015, which I think was another year. We don't have the satellite imagery for it, but it might have been, that was a really low snowflake year. Then was the warmest summer on record until this past summer. All that snow that accumulated since 2015, when you had an accumulation zone, is gone. So these heat waves are coming in and not only melting the past winter snow, they are removing all the stored snow too. So not having an accumulation zone is being on a starvation diet. And then these heat waves are coming in and like saying, hey, I want to get liposuction because my starvation diet isn't doing the job quick enough. And weight loss. And so these heat waves are actually, these weather events are now impacting the glaciers because they're so extreme. So that heat wave probably killed off Renfrew, killed off Lynn, because we thought maybe it could still have been slightly an active glacier in 2020. And it's removing any of the accumulated snow that happened in Collier. So Collier has now gotten no gains since before 2015. So this is hastening the ends of these glaciers. It's very, very bad. So what you could do, then on a slightly positive note, so instead of this negative, is one, support us. I will sound like OPB right now, or your local library asking for donations. We are only able to do this work by donations from concerned citizens like yourself. So we are a 501c3. Please go to our website here and you can donate to us. Contact your policymakers here. So the state of Oregon talks a good game, but it doesn't do anything when it comes to actually monitoring these glaciers. Neither does the federal government. So if Minnesota woke up and all of a sudden had about more than half of its lakes gone in terms of like what's happened here in the state of Oregon as a total, they would be doing something about it. But that's what's happening here. Oregon was a glaciated state, and now we've lost more than half of our glaciers are gone in the state. And that should be something that should wake people up and say, hey, we got to do something about that. So that means we need to stop using carbon-based fuels immediately and get ourselves onto a green pathway of using renewable resources and so on. And in helping our further work here, please, on our website here, send photos to us. So this photo here from 1971, we never would have thought there was any glaciers on Diamond Peak since before the 1950s. Here's that photo from 1938, taken by Ken Phillips. And okay, there's ice there. Well, that ice stuck around for another 30 plus years. And this was never put on the maps. The USGS never did anything about it, despite Ken Phillips working for the USGS. And so this really, you're all going back to your photographs before everybody had a smartphone, and sending to us would be great too. And lastly, if people want to come out and join us in the field, working on our field work, looking at the balance measurements, so going on and examining the glaciers and their health and activity, please let us know too, because we're always looking for citizen volunteers. And at that note, I will take any questions you may have. Thank you for your time.
I just want to say this is an incredible presentation about such an important topic, and I just want to thank you for all your work and your expertise in this field. And we're going to welcome audience questions, but I have a few here for you to get us started. Namely, can you tell us how you got started? We heard about your credentials and such, but did you wake up one day as a kid and say, I really like snow. I think I want to make this a career. Can you tell us how you actually got started on learning and studying about glaciers?
I grew up in the Midwest, and on my family farm, my grandfather had a boulder that he would always farm around, and one day they pulled it out. It was this giant glacial erratic boulder brought down from Canada in the middle of an Illinois farm field. And that was like kind of like, oh, wow, this is neat. And we would go do family vacations in northern Minnesota on the Canadian Shield, and it all was sculpted by glaciers. So I got really into it. And then growing up in the Midwest, when you get a chance to go to Alaska as an undergraduate to do research, you're like, heck yeah, I want to go to Alaska. And I just was like, this is it. I'm happy. And I've pursued it ever since. I have my resident day. So a combination of just childhood kind of being amazed by these things and loving glaciated landscapes. And so I wanted to spend it, whether it be Canada, Midwest, New England, or the actual in the mountains too. So that's how.
And is that how you came to be in Oregon? You've mentioned a few times now that Oregon, and particularly our part of Oregon, is one of the best places to study glaciers outside of Alaska. How did you end up here?
I came here because of the good research program at Oregon State University for studying climate change, glaciers, ice, and so on. And much of my work when I was an academic was focused more on ice sheet changes and sea level rise from that. And over time, I was realizing the results in what I was finding. At some point, there's only so much you're going to be able to say about the future sea level rise from this work. And I felt that the expertise, like the more immediate future problems pressing to us, were this loss of water resources. And so Jimmy Carter wrote a book, or he helped with Running Dry. And so the most immediate crisis we're facing on is a water shortage, whether in the United States or in the Alps or in the Himalayas or South America. And with these areas here that are fed by glaciers, that we're going to lose a permanent water source. It's like one day, all of a sudden, your tap runs dry. And so that I felt was an immediate, more pressing issue that was here in Oregon was not being addressed whatsoever. And you go up to Washington, there's a little more work up there because much of their glaciers reside in national parks, and the National Park Service keeps tabs on those for because they're in their park. But but here in Oregon, it was just people just didn't even know how many glaciers are here. They never updated the maps since the 50s, and that's why I was like, well, this is an important thing to put my effort towards. So.
Definitely. And speaking of those maps, how often are you monitoring these glaciers? The maps themselves are created by the government, but how about your organization? How often are you going out and tracking?
Well, we only formed a year and a half ago. So in the summers, we like to go out in August, September, early October, right before this. So when the snowpack is at its minimum and right before the first snow, you can see the most. So this summer, we went and did more work on Mount Hood because last year our work on the north side got cut short by the forest fires, all the smoke getting in the way. And then next summer, we want to get back to check on then the Three Sisters region again to see the impact of the heat wave. Satellite imagery really helps because you can look in quickly, but it doesn't get you the small minutia. If it does have crevasses or the meltwater stream that's there. So every year or two, we'd like to get to each glacier.
Well, it's a wonderful effort, and we're so very grateful that you're out there doing the hard work. And I really appreciate you also informing us how we as individuals can do the work. I know that sometimes this can feel like a daunting subject, and we can feel small in comparison to the work that has to be done. But I think you've proven to us exactly how much impact a single person can make, and also tell us about the citizen science aspect and how we can get out there and help out in our own small ways. Is there anything else you would like to share with us? Anything else that you forgot?
Just that, those photos are old photos from before 2010, or also if you go out and it's August, September, and you can take a photo of the glaciers when the terminus and send it to us. Those are great. A picture's worth 1,000 words, and a day of my life hiking too.
Yes, definitely. That's wonderful. And feel free to share those photos with us at the library. Also, we'd be happy to collect them and send them to Anders, send them on the way. Thank you so much for taking the time tonight to join us and to tell us all about this. And thank you to everyone who is in the audience out there. We appreciate you. We could not do it without you. And we are, of course, open. We are happy to see all of your faces eventually. And we just want to say we have a lot of wonderful, great, fun, free content just like this available at deschuteslibrary.org. So if you missed anything from the talk, don't worry, we've recorded it all for you, and we'd love to have you go to our YouTube page to find out for other great content. Anders, I'll let you go for the night. Say one last great thank you, and we hope again to see you soon.
All right.
Until then, have a good night, everyone.